All right, good evening, everyone, and welcome back to cloud computing class at Oakland University. So to continue our discussions, we had learned about the virtual private cloud setup in the last two classes or more so. And the few major things that we had learned in terms of concept with regards to the VPC platform was the fact that it had the cider block notations for networking purposes. So we learned about how to translate the cider block notations into the regular traditional IP address format that we are all familiar with. Then we also talked about two different types of firewalls. The first one was known as stateless firewall, and the other one was stateful firewall, and how the concepts of stateless and stateful firewall relate to the security policies that are designed on the VPC platform using security groups, which is applied at the instance level, where all your EC2 instances or your storage volumes are basically hosted. And then at your network ACL or NACL level, which basically governs the traffic that will go in and out of the subnets that you will design inside of your VPC. So again, to kind of do a very high-level overview of the virtual private cloud setup for any kind of AWS platform organization, within the VPC, you will have one VPC that will be by default created for each and every region within the AWS availability regions. So you will get a default VPC, or you can create your own VPC with your configuration details. So you're basically setting up a network for yourself. And in the default VPC, for every availability zone that is present inside the availability region. So for example, if you are working in the Ohio availability region, for example, there is 3 different availability zones within Ohio. So for each availability zone, a default public subnet is created as part of AWS, right? So if you want to make any kind of private subnets, you can either change the configurations of these public subnets to private, or you can create your own VPC and declare everything as a private subnet, depending on the requirements of your organization for whom you are making the setup, right? So that is something that you have to keep in mind. There are also route tables, which kind of dictates the communication and the assignment of IP addresses within the subnets, okay, or specifically for the subnets and all the instances that will be initialized within the subnets. There will also be an internet gateway to which IP address will be associated, so that you can kind of communicate between all of the subnets that are present within your VPC versus the outside world, which is basically the public internet platform or any other AWS services that can be pinged or that can be reached out to using the public internet infrastructure, right? And there are other options with respect to creating endpoints, with respect to creating elastic IPs, setting up VPNs, virtual private gateway, VPN connections, and those kind of things. What instances are running across all of the different regions that AWS has and that you have opted in when you're creating your VPC, the different security groups that are involved, the network ACL policies. So this basically gives you, the VPC dashboard essentially gives you a high-level overview of everything that is happening with your network deployment on AWS platform. So what we are going to talk about today is specifically the Elastic Compute Cloud, which is a part of infrastructure as a service. And what we are going to discuss is the high-level overview of the EC2 dashboard, how to launch instances, and what are the different aspects that are involved that you have to keep in mind on a fundamental level when you are working with instances. So to give you an idea of what will actually be involved when you're working with instances, that is going to be pretty simple. So if you break it down into very smaller chunks, smaller bits, and to try to kind of keep a track of all of those different smaller aspects, then understanding what is there when it comes to infrastructure as a service deployment on a fundamental level. Of course, there are different flavors of how you can do infrastructure as a service, such that if you're using infrastructure as a code and those kind of things, right? But at the very beginning, right, on a very beginner level, the things that you have to keep in mind is basically available on this overall dashboard. So here you can see that this is the EC2 dashboard. So if you don't know where to find this for, you can go to the search bar and just type EC2. So if you type EC2 here, This will give you the service, and essentially this will take you to this current page that we are on, right? Which is the EC2 dashboard, right? And this has the new AWS interface that we are working with, right? If you don't want to work with this, of course, if you're new to this, this is what you will be looking at. But for those who have already worked with AWS, and if you kind of don't like their new interface, then you can essentially turn it off. So once you're on the EC2 dashboard, a few things that you have to keep in mind are the different aspects. So the first and foremost is to make sure that you are in the availability region that you would like to be present. And this is where you will be deploying all of the different EC2 instances. So remember, whenever you're thinking in terms of instances, it is not a standalone virtual machine or a virtual server that you will be creating, right? It will basically be an assignment of that instance within a particular subnet that is associated to a VPC, right? So to understand this again, or to kind of recap this, the setup of an EC2 instance always happens. So at the very top, you will have your VPC, right? And this VPC will belong to a particular availability region. For example, in our case, the availability region is Ohio. And remember, for each of these, for within a particular VPC, which is basically deployed on an availability region, there will be many different availability zones. So for example, Ohio has 3 different availability zones in Ohio, right? And the default architecture of the VPC is that there will be one public subnet that will be deployed for each availability zone present within the availability region, right? So now when you think of an EC2 instance, okay, because that is the technical term that we are using in order to kind of refer to EC2 instance, we have to recall that all of our discussion that we made during the conceptual parts of the cloud architecture and stuff like that. An EC2 instance is nothing but a virtual machine, right? So you can think of it as a virtual machine, or you can think of it as a virtual server, depending on the type of operations that you want to associate with your EC2 instance. You basically call this, right? And this is running within a data server, a data center, right? And as we had discussed the architecture of the data center, so all of those architectures are essentially present in the underlying layers, right? So you have all of these different physical commodity hardwares. There's a hypervisor, there's a virtual infrastructure manager, a VIM, right? And all of them are creating these different instances. So whenever you request a particular EC2 instance, basically the hypervisor, when it gets to that point, it kind of creates the virtual machine, and then you are basically able to access that virtual machine, right? So when you create that EC2 instances, basically that EC2 instances is associated to a particular subnet, and that subnet could be public and private, depending on how you have configured that particular subnet. And that subnet is a part of some VPC that is running in some availability region, right? So you always have to keep this infrastructure or this deployment infrastructure in mind, because you don't have a standalone EC2 architecture, right? Or you don't have instances that are just floating around. They are a part of a properly well-knit network configuration that has been created, and it is present in some subnet, which is a part of VPC. So that is what you have to keep in mind in terms of the translation when you're working with the EC2 instances, right? Other than that, in the EC2 dashboard, just like you get a high-level overview of the different components that are associated to a virtual private cloud, you get that same set of high-level overview for all of the different components that are associated with the functionality of the Elastic Compute Cloud service, right? So that means it will show you what instances are running. It will tell you about the auto-scaling groups, and we will discuss auto-scaling groups probably in the next class itself. If you have requested any kind of dedicated hosts so that you don't want any sort of multi-tenancy to be present in terms of your EC2 deployment, then that will show that information here in this dedicated host features. It will show the instances that you have created. So the instances versus instances running, that is kind of self-explanatory, that if you have any kind of stopped instances or instances that are in standby mode that are not basically executing any operation, that will also be accounted for in addition to the running instances in this instance part. Key pair is basically used for authentication. So essentially, if you have created an EC2 instance which is running, Maybe you have stopped it, but mostly running, right? And you want to connect to that EC2 instance from outside the AWS network configuration, right? Maybe we are using one of our local computers in order to push some data or work with the EC2 instance using, let's say, SSH-based terminal access or remote desktop protocol-based Windows access, right? Then we need some sort of authentication mechanism in order to connect with these EC2 instances. So those EC2 instances are essentially authenticated. The connection is basically authenticated using the RSA scheme or the public-private key infrastructure. So that is kind of captured through the generation of key pairs, where a public key and a private key will be generated based on a certain scheme. And there are two different schemes that are available, and we will talk about them. And then you essentially always, whenever you're trying to connect to the EC2 instances using either SSH connection or DP connection, then you will have to specify your private key such that AWS can authenticate and provide you or allow you to connect with the EC2 instances, okay? Then we have the concepts of security groups. Remember, there will be no network access control policies that will be associated when it comes to EC2 itself, because as we had discussed, NACL is applied on the subnet level, okay? Whereas security groups are applied on the EC2 instance level. So as a result of this, when we're talking about EC2 specifically, we don't discuss or delve or deal with NACLs. We only deal with security groups, right? So in the security groups, if you again recall our discussions from the last class, by default, security groups are designed to drop every incoming connection, okay? But if an incoming connection is allowed, then it also allows the outgoing connection to that particular traffic, whichever is being allowed, right? So we have to edit when we have launched our EC2 instance, we have to essentially edit the security groups in order to allow it to have SSH connection and RDP connection, okay? So basically one is port 22, which is for SSH. And then I believe it is port 443 for remote desktop protocol, but we can double check that when we are setting that up, right? So that is one of the things. Then there is volumes. Okay, so volumes essentially means like the storage that you will associate with your EC2 instance, because the EC2 instance will give you how many number of, or basically will assign the total number of virtual CPU cores that you want for yourself, the memory that you want, which is the RAM size and all those things, and what category of EC2 instance that we're trying to launch there, right? There are 5 different types of category. We will discuss about that. So those are the different volumes, right? So here, let's say if you want to associate a single SSD, which is, let's say, of 8 gigabytes, which will handle your storage, right? Not your main memory, not your RAM, but basically the storage that will save your data and any kind of configuration files and so on and so forth. So that is basically what we talk about when we are referring to volumes, right? You can attach that volume, you can create it separately from the generation of the EC2 instance, and you can attach it to other EC2 instances as well after detaching it. So at any one point of time, you can attach one volume to a given EC2 instances. But that is the flexibility that you have, that if you're done with working with that one EC2 instances and you just want to detach your volume and attach it to some other EC2 instance, that is also something that you can do as well, right? Snapshots are basically snapshots of the volume. So that means that if you're done with the volume, you just want to keep a storage of the data. And later on, if you revisit your platform and you want to create a new volume, but based on old data that you have already created. So what you do is you basically create a snapshot of your storage volume, and then you can save that snapshot as well, okay? In addition to that, one of the last features that is available is basically your load balances, okay? And placement groups is basically targets. We'll talk about that when we talk about target tracking. It is associated with load balances itself. So if you want to keep a track of the load on the CPU, for example, on your different EC2 instances. And based on that, if you want to balance out the workflow that is coming to your different EC2 instances, if they're acting as, let's say, service or web service and stuff like that, then what we essentially need is load balancers, right? So to summarize the different things that you have to keep in mind is how to launch an EC2 instance, okay? How to generate key value pairs for authentication, and then making sure that you can connect to those EC2 instances. That is the second task that you have to keep in mind. how to work with volumes and snapshots. That is pretty straightforward. There's nothing much to be worried about here. How to edit security groups, add new connectivities to it, add new network traffic so that those traffics can actually reach out to the EC2 instance. Because if you do not touch upon this security groups, then by default, all traffic will be dropped and you can never reach or ping your EC2 instances that you create. And then the last two features is basically how to create auto scaling groups that let Amazon keep a track based on the policies that you define on how many minimum EC2 instances do you want, what should be the maximum, and what should be the average, right? The typical way. And that way, using another service, which we have already seen in action, that is known as CloudWatch, Amazon can keep a track of the health of the EC2 instances that will be basically managed by it, right? And then finally, you have the concepts of load balancing, which allows us to distribute the workflow based on certain target tracking policies, which is the target groups, right? That we have to keep in place, right? And target tracking policies is basically another way of saying that, hey, monitor these, let's say 5 EC2 instances for their CPU load and make sure that that load doesn't go above 80%. So that make sure that it doesn't go above 80% is something that the load balancers will keep a track of. And when we create the target groups will allow us to specify which EC2 instances are we tracking and what are we tracking for, essentially, right? And when that event gets triggered, then load balancers using auto scaling groups is going to take some actions, right? So that is basically what we have, okay? So moving forward, what you have to keep in mind is we have to revisit the IP addresses a little bit, okay? There are 3 different IP addresses that is available for your usage when it comes to EC2, right? We have already discussed 2 of them, which is a public IP and a private IP, right? So if you have a private subnet, then private IP will be associated to it. Even if you have a public subnet, you still have a private IP that is associated with it, right? Because if you remember the architecture of your VPC, right? Within the availability regions is where you have either a public subnet or a private subnet, right? But the way the communication happens just between the subnets is through the help of a VPC router. And the VPC router is associated with a CIDR block, which has a very large chunk of IP addresses that are associated with it, right? So even a public subnet has a private IP that is associated with it, such that the subnets that are actually private can use that private IP to communicate with the public subnet. Okay, so this is just a subtle distinction that you have to keep in mind, that just because if a subnet is public doesn't mean that it doesn't have a private IP address. Every instance or every subnet has a private IP instance, a private IP address, and that is the address that it uses in order to communicate amongst the different subnets. But in addition to a private IP address, public subnets also have a default public IP address, and this public IP address is visible to the outside world. So essentially, if there is a communication that needs to take place from outside of this trusted boundary of the VPC, that, let's say, if it is a local machine, like our computers that we're using right now, or if it is a AWS service, which is basically reachable on the public internet infrastructure, then if those services, right, if they are trying to kind of reach out to an EC2 instance, and granted that EC2 instance is present inside the public subnet, then we need to essentially use the public IP address. Okay, so that is the difference between the public IP and the private IP addresses, right? So the public IP address, it is dynamic in nature, and anytime you stop the instance, that IP address gets purged, right? So when you restart the public, that EC2 instance, which is present in the public IP address domain, right? You have to make sure and double check that the IP remains the same, or has it changed, right? Since the last time you stopped that instance and you're turning it again, right? The public IP address is specifically used for the public subnets. And the reason why it is so is because it is visible to the internet, and the internet can use that IP address in order to ping the EC2 instances that will be present within the or associated to that public IP address. There is no cost that is associated with public IP address. It is given to you for free, okay? But it is also coupled with a private IP address for that particular instance. And the reason why you have a private IP address for EC2 instances which are present in a public subnet is to basically enable the communications between the subnets itself. So think of it this way, that private IP addresses are used for internal communication between the EC2 instances amongst the subnets, right? And then the public IP address is specifically used for communications that is going to happen through the internet gateway with the public internet itself, right? One of the major drawbacks is that you cannot take the public IP address, which is assigned to a particular subnet, and reassign that to a different public subnet. So that means, for example, here, we know that we are dealing with 3 different subnets, right? We know that for a fact, we have checked it, that Ohio has 3 availability zones, and the default VPC architecture has 3 public subnets. So each public subnet will have a specific public IP that is associated with it, and that will be inherited by all the EC2 instances that will be present there, right? You cannot take the public IP of one of those EC2 instances and port it across to another different EC2 instance that is running somewhere else. So that is one of the drawbacks, and you need to keep this drawback in mind, because this is the major distinction factor between public IP and elastic IP, okay? Whereas private IP is just for internal use, that is the communication between the subnets that will take place through the VPC writer, okay? And every instance will have a private IP. But instances that is present in a public subnet will, in addition to the private IP, will also have a public IP that is associated with it. The other thing is, private IPs are not purged as compared to public IP addresses when the instance is stopped, okay? If you terminate it, it's gone from existence. There is nothing to kind of get it back there unless you have created a backup of it. But here we're talking about stopped and not terminated. That is the distinction, okay? And then this private IP address can be used for both public, or it is used for both public and private instances. In contrast to the default public and private IP addresses, there is also another type of IP address, which is generally referred to the acronym using the acronym EIP, or basically it stands for elastic IP address. So what this is categorized as is a static. So that is something that it does not changes, and it is also public in nature. Okay, so you can assign static IP addresses or elastic IP addresses for free. There is no charge when you just create one and assign it. However, if you do not use the IP addresses, that means, let's say you created an elastic IP address, assigned it to an EC2 instance, but the EC2 instance has been stopped, it is not functional, and you're not using that instance, right? So essentially, as a result of that, you're not using the elastic IP address either, okay? If that is the case, then you have basically fallen into that condition that we had discussed before, that you have asked AWS to allocate you an instance, and that instance essentially has been allocated by reserving whatever underlying hardware resources or has been given to it, right? But then you're not using it. And if that is the case, then this is the price that will be charged to you for unallocated use of reserved instances, right? Yes, question?
Yeah, what if you have a DNS-A record associated to that IP address?
Say that again, slowly.
What if you have a DNS-A record associated to that IP address? How does that work?
What do you mean, how does that work?
I mean, you have an instance that's stopped, but you have, and the IP address is going to be recycled into the pool, I take it.
Yeah, so you cannot ping it. That host will not be reachable.
What happens if another host comes up with that? Does DNS?
No. So that's a reserved allocation.
Oh,
so
okay.
Until and unless you destroy that, it is not going to be allocated to another host. So that is why this point is there, that if it is not being used, then and only then you will be charged for that reservation, because that is the problem, as you pointed out, that we cannot give it to another host. So basically, it's an IP address, static IP address, that is essentially just sitting there and doing nothing.
That was what I was wondering. Thanks.
Yeah, so that is where the cost part comes from. Okay, all right. And another advantage of people using elastic IP addresses is because this IP addresses is not specific to a subnet or an EC2 instance, right? So this is an allocation that happens on the network access cards. Okay, so that means this allows you to port or basically associate that allocation, that reservation of that static IP address to any EC2 instances that you wanted. So for example, you, let's say, start off with an EC2 instance that has a certain configuration level. Then later on, you realize that your organization has grown, and then your peak capacity has changed, or the business model of your organization has changed from, let's say, throughput-based tasks to compute-based tasks and stuff like that. Some hypothetical examples I'm giving you. So you decide that you have to change your EC2 instances altogether, or you have to change your VPC architecture altogether, right? However, you don't want your users to be given a new DNS, right? Or a new web address or something like that, right? That is again controlled by the domain, but that's a different issue. So what you do is you basically take the reserved elastic IP that you have created, right? And you just attach it to the new EC2 instances that needs it, right? That essentially will be the new home for your application, for your server and things like this. So that is the benefit of EIP, but it also comes with the risk that at any point of time, if you stop using it, then they will stop charging. Otherwise, it is completely free. That is something that you have to keep in mind. And when it comes to remapping, AWS allows you to remap up to 100 times a month. That is a lot of remapping if you actually think about it from a practical perspective. Okay, so if you go on remapping for whatever case, more than 100 times a month, and I cannot think of a practical scenario where this might sound reasonable, that you have to remap an IP address more than 100 times in a given month. That is more than twice a day, even thrice a day. You are remapping your IP address for some weird reason, then there is a cost that is associated with it, right? So these are the two avenues that you may incur cost when it comes to elastic IPs on the AWS platform. Okay, this number may have changed over the year, right? So you can double check that to know the exact amount, but know the fact that there is a cost that is associated if you have reserved a static public IP address that is known through the elastic IP address, but you're not essentially using, right? So these are three different types of IP addresses that you will essentially encounter in AWS EC2 platform, right? And it is helpful for you to know. You don't have to remember word for word, but conceptually how these IP addresses are differing. What are their benefits? What are the disadvantages? To have that understanding will be helpful for you to decide whether you can, let's say, get away with the public IP address, or do you need to assign an elastic IP address or not, right? More than often in production environments, you will end up using an elastic IP address, but just please make sure you keep in mind that you're not using it, right? So that is something that you have to keep in mind. Okay, so let's move on to launching our EC2 instances. So everybody please log into your AWS account using your IAM user that you have created, that I have shown you, and let's talk through the different types of aspects that are involved. Again, the slides that I'm showing you, it is available on Moodle. So those who want additional reference, additional support, please start looking into it from slide 7. It has a step-by-step instructions of exactly what I'm going to talk about. And I will also follow that instruction, so you don't lose me in case you are following those instructions as well. Okay, so all right, so everybody ready? Just log in. That is what you all need to do in order to get ready. And I'm working in Ohio region. You guys are free to work in any region that you want. Just try to not choose anything outside the North Americas, because that will again create problems of latency and stuff like that. And let's just avoid that. So just try to stick between Ohio and Virginia. That will be my suggestions. All right. So what do you need to get familiar with? We already talked about the high-level dash. Okay. On the left menu, familiarize yourself with the different aspects that we have, right? So the first one is everything with respect to creating your instances. So you can either choose to go to instances here, and this will take you to that old interface where you can launch your instances. Or if you want to do it from the dashboard, the way to launch an instance is through this particular button here, which is launch instance. All right. On the right top corner, please make sure that you are in the VPC that you want to work with. Okay. And everything else, you don't have to worry about it for the time being. There are some unnecessary information. You can close these things if you don't want to kind of look into it. So I'll just close it. Documentation is always there. They don't like us removing the widget, so you can give the feedback and stuff like that, and I'll just say the content is distracting, and you can remove it and you can focus it here. Okay. The next thing to keep in mind is instance types. Okay, so this is an important thing, because if you remember when we're talking about generic cloud computing, we talked about the fact that there are profiles or templates that are associated where you can just select a particular profile, and with that profile, you have the different aspects of launching a VM that is associated with it, right? And what are the different aspects of launching a VM? Well, basically, you have how many CPU cores that you want to use, right? That is the processing. Then you have the architecture of the CPU that you are selecting. How much memory do you need? And when we say memory here, remember we refer to RAM, okay, a random access memory. We don't talk about the storage, right? Storage is completely separate. Storage is where the hard disk drives, the solid state drives, those kind of storage that is associated, okay? We also have the storage type. If we talk about the SSD, the HDD, and those kind of things that is associated when it comes to instance types. Then we have the network performance. That is how much network latency will you kind of incur, and how much network peak performance bandwidth will you get depending on the type of template that you select. How much will it cost if you're running a guest operating system distribution, which is of Linux type, and how much will it cost if you're running a Windows instance, okay? Mac is different. Mac has a different price altogether, so you will not see that in the general display as well, okay? When it comes to our free tier account, right, all of these different things are available across, but there are some prices that are associated. When it comes to free tier, we can only use what is known as the T2 micro, or in regions where you do not have the T2 micro, then you can use the T3 micro. Right? So essentially what you have to kind of get familiar with is knowing the fact that we are going to be using T2 micro almost all of the time when it comes to launching a EC2 instance itself, right? So you can check that we just get one CPU core, that is not much. We have 1 GB of memory, right? Just decent enough for small operations and all our demo and understanding how this environment works. We get a low to moderate network performance. Of course, this is multi-tenancy because we're not going for any kind of dedicated host. And we get some free storage, and that storage will be a general purpose storage of up to 8 GB, right? You can go above that, but it will start to cost and stuff. And this is the regular pricing. We will not be charged for the first 12 months, but after the first 12 months is over, then this is what you pay for every hour of the EC2 instance usage of this particular instance time. Now, what is important for us to understand is that there are 5 different categories of these instances, right? Of course, these numbers are going to change the amount of resources that are allocated to you. That is true, right? But there is a specific type of category which is more tailored or customized towards certain different operations that you would want to run on their platform using their infrastructure as a service. So everything that starts with a T here, this is basically known as general purpose instances. Okay, so they are not kind of customized or specialized for a specific type of job. It is to host all different types of job that you have out there. So that doesn't mean that they're bad, right? Because if you keep on going for, let's say here, if you go for the T2 2 extra large, okay, you can get 8 CPU cores up to 32 GB of RAM, and it gives you moderate network performance, right? That is something that we can deal with, right? And that is something that even my local computer has, right? It has more than 8, but that is essentially something that is a very strong computer for any kind of general purpose behavior, right? So if you keep on going here, I don't know if we can change this. No, we cannot show it in one page. The old interface used to show it in all one interface. Anyways, but if you keep moving down this page limit, you can see that slowly from T, the instance type categorization has changed to C, okay? C stands for compute optimized instances, okay? So that means if you are basically requesting resources from AWS and the job that you're going to execute on these VMs are computationally intensive, then essentially you would want to rent out an instance which is not general purpose, but compute optimized, right? And any type of compute optimized instances starts with that C category. Okay, so that basically refers to the fact that it is C. And now you can see that if you move into the C, right? Let's go to the previous page and see what was the last, where's the first C instances that starts. Okay, So it starts from here itself, right? So here you can see that when it comes to network performance for computationally intensive jobs, the network performance gives you a bandwidth up to 10 gigabytes. That's a lot of bandwidth, but it also costs you significantly more than general purpose instances as well, because of all of these dedicated services that they are giving, right? So, but you can see that the amount of resources that they are going to give you is going to be a lot, right? So this one, as you can see, the C5.metal particular instance type is going to give you 96 CPU cores with 192 RAM. Gigabytes of RAM with a guarantee of up to 25 gigabits of network bandwidth. That's a lot. Okay. So you can see that if you want to run any type of computationally intensive job, then that will allow you to kind of, or you should go for these C-type instances that are available to you. For free tier accounts, we don't have anything other than T2 or T3 micro. So we will not be seeing any of these in action, but this is something that you have to keep in mind. Okay. So the next one, so we talked about the compute optimized, right? But then there are ones which are memory optimized as well. So I'm looking for instances that will start with memory optimized. So these memory optimized, which are starting with M, okay, these are all memory optimized. So any kind of job types which needs to be executed within memory, right? Let's say you have a lot of these new generation querying operations which needs to run on inside the memory itself in order to reduce the latency that it takes to bring the data back and forth and then query them within the memory, right? So instead of storing the data within your storage volumes, you can basically store it in the memory itself and then query it, and that is considerably faster compared to your regular querying operations, right? So one example of such a application is the Apache Spark. That is the architecture that is essentially used to keep the data in the memory and then query it directly from there, right? So if you see these M type of instances, as you have guessed here, the memory is considerably large compared to the general purpose and the computationally intensive. Then you have categories of instances which start with D somewhere. So the R ones are also memory optimized, by the way, not just the M ones, but the R ones, these are also memory optimized as well. And then you have storage optimized and then GPU enabled. So if you look for anything that is G based or that has some sort of GPU, and this interface, that is the reason why I don't like it, because we don't see it in a instance here, right? But essentially there are certain instances which are optimized for GPU operations. So that means, let's say if you are running some sort of operations that is machine learning on images or machine learning on audio, and you need EC2 instances that are kind of optimized for handling these different input data points, right? And then processing it using a machine learning algorithm and stuff like that. So you would essentially want to take an instance or rent out an instance type, which is GPU enabled, right? And similarly, if you have any kind of job applications that requires you to perform a lot of serial input output operations and bring data or read data from the storage and then write data back to the storage, right? So basically you're not performing these operations in memory, but it is something that requires a lot of disk input output. Then you need to rent out these storage optimized EC2 instances, right? Which starts essentially, characterization starts with the D letter itself, okay? And there are other letters as well, which falls in this set of categories, but these are the parent set of categories that are essentially available to you when you are thinking in terms of renting out an EC2 instance. Okay, so this is something that you have to keep in mind. So the key takeaway is not to memorize these numbers, because you cannot. As you can see here, there are 566 different types of instances when it comes to each and every. So it is humanly not possible for you to remember every one of them. What is important though for you to remember are the 5 different parent categories of instances that EC2 provides you, right? So you have to remember that there is a general purpose, there is a compute optimized for computationally intensive tasks, there is memory optimized, so that is tasks that you're going to run in the memory itself, storage optimized for operations that involves a lot of serial disk input output operations, read write operations, and GPU enabled operations that is kind of self-explanatory. That is, if you need a lot of GPU support for any type of task, then that essentially gives you the different types, right? So in the chat, okay, that's a direct message. So we got a link here which shares us the different, right? So okay, so this is helpful. Yeah. So we got this link from one of our members here. So this basically gives you the summary of all the different types of parent categories of instances that I was talking about. And then you can check it out here. What are those difference operations, right? So this is kind of helpful as well. So you can keep this in the EC2 instances. You're basically looking at instance dash types on their documentation page. And that will give you the different categories. So now they have added a category which has been differentiated from compute optimized, which is high performance compute optimized. So this basically you can treat it as a child category of compute optimized as well. But if you have specific needs for HPC, then you can look into the categories of HPC, and it gives you the different types of templates that you can select and what are the features that is available. A lot of features, man, come on. Ooh, it's a 1 terabyte of operation. So this is something like you have to wonder, right? They have a lot of resources that is available to you. Okay, but that is essentially the key takeaway of the different instance types that you will be dealing with when it comes to working with EC2 instances. Okay, all right, so that takes care of the instance type. And then you can go to different launch templates. So launch template is basically where you would want to create your own launch templates, right? So if you want to decide what for your organization launching an EC2 instance will look like, what are the additional software stacks that you want to implement when you're launching the EC2 instances, then all of those different things can be basically created through launch templates. If you do not want to use any of the, if you do not want to create your launch template from scratch, you basically will go to this section of images, where you can see here you have the Amazon machine image, right? So if you go to Amazon machine image, or if you go to the marketplace, which is known as the AMI catalog, then you will find here all of the different popular options. And then you can see here that for each image, which is basically an OS distribution, so to speak, that's what the image is, the machine image is all about, it says free tier eligible. So right now, if you don't want to pay money, then you want to use a instance type, which is free tier eligible. So don't use these things, which does not say free tier eligible. So anywhere it doesn't say free tier eligible, if you use it, you will pay whatever money that is associated with that particular cost model, right? So Amazon has its own version of the Linux distribution as well, which is the one that we'll be using for our demo purposes most of the time. Okay, so that is known as the AMI Linux 2 version. Okay, right now the most highest version is the 5.10. I think the last time I used it, it was around 4.14, but I don't remember exactly. But essentially the whole goal for you to understand from this is that you can go to the AMI catalog, which is basically the marketplace for all the machine images. You can look at the trusted third party or the verified images that has been given. So there's a lot available. Or you can go to the community AMI location, where anybody like us can create a launch template using this particular option here, and then they can submit it to AWS, and then others can use it, right? So there are some interesting stuff going on here. Okay, so and then the other stuff, the dedicated host, the reserved instance, the capacity reservations, we're not going to do that because we don't want to kind of pay for that right now because we have no purpose in our demos. So what we are going to do is go back to EC2 dashboard, make sure everything is good, and just click on launch instance and then launch instance. This will take you to their new interface. This was not the interface that we dealt with, but this is a new interface right now when it comes to launching an EC2 instances. So let's say we want to give it here. So we can say demo EC2 instance. So we can give some sort of name here. Now here, the first thing that you have to specify when you're launching is the type of EC2 instance that you want to work with. Okay, so here on the right hand side, you can see that AWS, given the type of account that we have already pre-selected the different options that will be associated to this EC2 instance that we're launching. So in one go, you can launch a number of EC2 instances with the same configuration. Right now, we're just starting with one. Then the second step is to select the machine image. Okay, so the machine image is the same set of images that we saw. If you go to browse more AMIs, that will take you back to the AMI catalog, which can also be found from this right-hand corner here. So here we will always select, not always, we can also select the windows here for free. It is somewhere. So we will just, if you cannot find something, just search for it here. As they have already said, if you cannot find Windows, just type Windows and it will show you the Windows stuff. So we'll come to Windows a little bit later. Here, we will just select the AMI Linux version 2. Okay, we hit select. It'll come back, show this, make sure it is free tier eligible so that we have not selected any other distribution and stuff like that. And the root device type, you're going to be using the Elastic Block Storage and stuff like that. For free tier, the instance type is going to be T2 Micro. Again, remember, T2 Micro is basically a general purpose instance. It is not bad for any particular task. It is not great for any particular task. That is the whole point of general purpose, right? But in a production environment, you have to ask yourself, what type of job are you going to run on these EC2 instances? And then based on that, given the different categories of EC2 instance types, you should select the instance type that best meets your requirement. All right. The next thing is we need a key pair login for basically authenticating or SSHing into our EC2 instances. Remember, without this, we cannot essentially ping our EC2 instances that we have generated. So the next task is to make sure that we create this particular EC2 instances and then set up our, our security group policy as well, which will come, I believe, right after. So here I'm going to click on create new pair. So I can say here, demo dash Ohio key pair, right? Let me just remove this and put a underscore here because we will be making use of this operation in terminal. Okay, but you have two different operations on how you're going to generate, or what scheme are you going to use to generate these key pairs. You will get a public key and you will get a private key. So hopefully everybody has some knowledge of how public private key cryptography works. If not, you can just refresh your memory and you can save it, right? You can kind of get up to speed with respect to how those tools work. So we are going to use the more well-known scheme, which is the RAC scheme. Okay, so we're going to stick to that. There is also another scheme that is the ED25519, right? This is basically curve cryptography or the elective curve cryptography based variant. So this essentially stands for Edwards curve digital signature algorithm, right? So there's a lot of words there, but you can check it out. And this one is named after the inventors of the scheme, which is Revest, Shamir, and Aldelman, which stands for RSA, which is a better known. So we're going to just select RSA, and we get two options on how the private key will be generated. So basically what the public private key cryptography will allow is that AWS will keep the public key and we will keep the private key. And when we try to log on to our EC2 instances, we need to provide this private key file, right? Which we need to keep on our local system, all right? So when we provide that file, AWS will kind of implement this scheme and be able to verify that it is you that who is trying to connect, right? So we are going to use the .pem file extension because we are going to be using our SSH. If you ever are in a situation where you have to use PuTTY, then you will use the .ppk format. And by the way, at least until a year ago, they did not have this functionality of PPK. That we had to actually go through the process of converting a .pem file into a PPK file in order to use it with PuTTY. You can check the slides for that instruction on how that is done, just as a good know-how. But now all those steps are not necessary because AWS interface, they have caught up and they're giving the option to download this. But anyways, you will use the .pem, okay? And then we will just click on create key pair, right? So you can see that when you create a key pair separately, that is, if you had created a key pair from here, okay, then it would have asked you to download that key pair separately. But since we are doing it, whoops, did I just lose all my work? Yeah, I just lost all my work. Anyways, so since we are using this wizard here, okay, in order to launch our stuff, then essentially it auto downloads it for us and we have to save it somewhere. So please keep in mind that you need to keep this .pem file for all the authentication. So keep it somewhere that you can easily track it. And let me just redo all of this stuff here. Demo-EC2 Ohio. Okay. And then browse for more, select this. Right, T2 micro, we will select an existing one, which is our demo_Ohio key pair that we already created. Okay, so the next thing is the network settings. Now in the network settings, the first thing that we have to do is we have to create a security group, or we have to create a new, or we have to edit a new existing security group. Remember that for every VPC, a default security group is available to you. So you have two options at this point of time. You can either choose to edit the inbound rules for the default security group that is present, or you can create your new security group, and then that will be given a name. Here, Amazon is telling us that they will say that it's Launch Wizard 1 because we are creating it using this Launch Wizard. And the initial traffic that will be allowed to it will be basically an SSH connection that can be done from anywhere. Okay, so if you want to change this, then you can put a custom IP address. Or if you want to use the IP address for this computer, right, then you can provide the local computer using which you're trying to connect to that particular IP address, right? So these are the different options that is available and that you can use in order to connect to your computer, okay? So here we will keep it as public, okay, so that any computer from anywhere can connect to this SSH or this EC2 instances, which will later be destroyed, essentially. When you can see that it gives you a prompt here, that setting it as 0, the CIDR block of all zeros, essentially means everything. And this is something that AWS doesn't recommend. If you have an endpoint, that is, if you're creating a web server and then that web server needs to communicate with this EC2 instances, then you can allow for HTTPS traffic, right? And other things also is available. All right. So here, this is a benefit of working with the security group and the Launch Wizard, that it does the job for you. But always remember that if you're trying to create your own security group, you just go to the security group area, which is here, and then you can create a security group itself, and then you can add that security group. Let me see that without leaving this, if we can just do the security group. Okay, so this is the security group interface here. And what we are going to do is we can click on create a security group. And here we can say demo SG Ohio, right? We can give it a name and we can give here allow SSH and RDP connection traffic to EC2 instance. So we can give it, and it needs to be assigned to a VPC. So this will be assigned to the VPC, which is basically Ohio. And then here you can see that there is no inbound rules. So remember, it drops all inbound rules. So we need to add an inbound rule. So we need to check here for SSH first. Okay, so we will select SSH, and CIDR block, we will just say everywhere. So basically this will allow us to SSH from any computer to EC2 instances in the security group. Okay, and then let's say we want to add another rule, and here we want to add a rule for remote desktop protocol. Okay, so this is basically 3389. This essentially allows that if we have an EC2 instance which is running Windows and we use a RDP client in order to connect to that, then that connection will also be allowed. So here we will say from anywhere. Okay, so essentially RDP from any computer to EC2 instance in the security group. Okay, so we can add these rules. So similarly, if you want to, let's say, add one more rule, let's say we want to do an HTTP web server, right? So if you want to do an HTTP that is running or using the TCP protocol 80, and then we want it to be able to ping from anywhere, that is any traffic that is trying to connect to, let's say, a web server that is running on an EC2 instance, which belongs to this security group, then you can ping it. So what we can say here is that ping web server running on EC2 instance from the internet, something like this, right? So basically, this will allow you. And you can see here the outbound rule, we are just making a generalization that we just allow all traffic to go outside from our security groups to wherever you want to send it. If you want to connect it to other EC2 instances, other AWS service, other computers, whatever it is that you want to do, you can essentially do that, right? So we don't want to touch the outbound rules. We can just keep it as is. Once everything is done, it's the inbound rule that matters more in the security groups. When this set is done, and this is demo SG Ohio, I want to remember this, I will just say create security groups, right? So it will create the security groups, everything is done. You can check, you can test if these different rules that you have applied to your new security group, which is now called demo SG Ohio. This is the name I have given. You can give it whatever name you want. It has nothing to do with it. You can check that, right? So once that is done, we can go back to this. And now instead of creating a security group, what we can do is we can select an existing security group that we have created. And this will take some time to kind of show up. So here it is. So I just refreshed it. If it doesn't show up on your interface as well, just refresh it, because AWS will take some time in initializing all of this stuff from time to time. So we will just select this demo SG security group. So now I have associated the security group that I have created outside of my wizard, and I have associated that to my EC2 instance that I'm trying to create. Okay. Now, next step is to basically add a storage volume. You can choose to not do it as well, but then that is going to be a problematic scenario because you have no way to store your data that will be generated from your instance, right? So it's better to just use the wizard. And the default is it gives you a general purpose storage volume of up to 8 gigabytes. That is what you have. You can take up to 30 gigabytes of the elastic block storage general purpose, or you can choose a magnetic storage, which will be a little bit slower than your SSD. So it gives you an SSD of 8 gigabytes for free to use up to 30 gigabytes. That's a good deal, right? If you want to attach new volumes, you can add new volumes here. If you want to create a volume outside of the EC2 instance that you can attach, detach, so you want to keep it separate, then you essentially will go to the left-hand menu again, go to Elastic Block Store, go to Volumes, okay? And here you can see that no volumes has been created, so you can just click on Create Volume, and then you can follow the process, or you can let this person here, which is the launch wizard, to take care of it for you. So we're going to use the launch wizard for now, and we're going to let it take care of it for us, because that's not anything complicated that we need to work on it separately, okay? Then going into advanced details, you have a lot of different fields with respect to requesting spot instance. If you remember, spot instance, dedicated host, reserved host, and then on demand, right? So that is where this spot instance is coming from. If you want to associate this EC2 to an IAM instance profile, that is if you have created a role, and if you want to assign, because remember, when we talked about IAM service, we said the fact that not just users, but other not EC2, but AWS services can also assume the role of IAM groups. So that means you don't just need to have groups of, let's say, admin, front-end dev, back-end dev, database developers, but you can put different AWS services, such as this one, EC2 instances, or S3 bucket, or RDS, AWS RDS, and those kind of things, and associate permission policies to that as well, so that they can communicate with each other, right? So here we don't want to associate to any particular IAM instance profile, because the only profile that we have right now in our ecosystem is that of an administrator. So we don't need to create any or associate this to any kind of permission policies. Let it be as such. Then there are a lot of different behavior options that is provided to you. So how are you going to recover your instances? When you click shutdown, what is going to happen? Is it going to stop? Is it going to terminate? How about hibernation option, terminations? If you want to protect it from accidental termination by mistake, right? I click the back button, accidentally it gone. So if something like that happens, of course, that is not going to happen. But anyways, so all of these different options that are available to you. But what is more interesting to us right now, and that I want to point your attention to, that in the advanced options, at the very end, there is a field called user data optional, right? And this is the interesting part, because here you can write your scripts to install additional software stack or whatever it is that you want to do within this particular machine. So right now, let's say I want to turn this machine into a web server. Remember, we added a security group rule here. Where is it? So we added a rule here, which allows for HTTP connection, okay, on port 80. That is basically an Apache web server. So what if I want to create those EC2 instances, but I have a personal requirement, okay, that I want to convert this EC2 instance and make it a web server that people from outside can reach, ping it, right, using the DNS IP address and all those stuff. So what if you want to do that? So let's say if you all draw your attention to around slide 31, okay, which is to create a static website. It's not going to be a dynamic web application, so there is no backend running. If you just want to host your own website using EC2 instance, so that is basically the exercise that we are looking into, then that is what we need to do, right? So if you want to do that, the way to install those software stacks is either through using this particular field here, or create the EC2 instance, connect to it using SSH, and then using the terminal, you can run those individual commands in order to install it. But let's say we want to do it here so that, you know, at the same time, we can understand the process of creation of an EC2 instance. But in addition to that, kind of implementing our own software stack as well. And the exercise involves here is to kind of install the software or make this EC2 instance into a web server that uses the HTTP 80 port, okay, not the HTTPS. So the way you need to write, and at the very beginning, this is how it's a bash script. So for those who are familiar with writing scripting, okay, bash script and stuff like that, if you have taken a system administration course before at OU and stuff like that, then you will essentially follow this. Yes, question.
Given that you can also spin up a Windows instance, is there a similar thing, or do you use bash there too?
You will use bash there too.
Okay, thanks.
Okay. But you can use other Windows scripting languages as well if you are launching Windows instances. Okay, so the bash script, you will start with this hash implement. Don't copy paste it from the slides, because it is going to change the encoding, and then AWS will not be able to recognize these commands. So don't do a copy paste, type it out, okay? We need to make sure that we don't have any kind of these hidden characters from Microsoft slide coming into this picture and then messing up the installation, right? So there is option where you can use sudo apt get installed and those kind of thing. There is another option. Basically, you can use yum to install it as well. There are yarn, there's npm, but these are all for different operations. But as long as you get the whole gist of how to install different applications on a Linux distribution, right, then you can work with it, right? Windows doesn't have their own inbuilt stuff. So you need to either install, let's say, npm or pip, and then go forward with whatever you're trying to install or the packages that you're trying to install from there, right? So here I will use yum, and I will say yum install, and then I want to install an HTTP daemon, right? Because that is where the web server daemon will be installed. So essentially I will say HTTP daemon, and I will give a -y in order to say yes, because anytime you try to install a application and stuff like that, Linux sometimes prompts you, these many packages will be installed. Do you want to install it or not? And you say yes or no and stuff like that. Okay. And then in addition to that, let me just remove all of these extra spaces and stuff like that. Okay. And then we have to start the service itself. So we will say system CTL start service and then HTTP daemon. Okay. So basically install, start the service, and enable the service for operation itself. So here we will say system CTL and then enable, okay, and HTTP daemon. If you don't know what is happening right now in the bash scripts, that is absolutely fine. What you have to understand is that we are writing a bash script. So the very first line indicates to AWS platform when it will launch the instance that this is a bash script that will follow. The first line installs the HTTP daemon service because we're trying to create a web server. Then it will start the service after installing it. It will enable the service so you can reach to the service. And then the last two statements is basically creating our HTML page that can be shown to the users if the user decide to ping our EC2 instance. Okay, so the last two set of commands is that we will change our directory into the location where we need to host our HTML file or our website. So typically, The directory for that, when it comes to Linux distribution, is /www/html. That is where you need to paste your file. Okay. And what we want to essentially put there is basically an index.html file, because remember, within this folder, the landing page or what the HTTP daemon will look for is a file called index.html. Okay, given that it is a static website. So you want to create the first file there as index.html, and then you can create your directory structure for your website and stuff like that. So if you do an exercise with GCP or Azure, this is one of the first exercises that they're going to show you in most of the classes, right? So the next thing that we want to do is run an echo command. And what we want to echo is basically take a sentence and we want to echo that into the index.html file, okay? Because there is no way for us to go to a text editor, create our index file at this location here, right? We don't have that interface. If you want to do that, you have to basically create the EC2 instance without installing all of these stuff. And then you have to sign into your EC2 instance using SSH or RDP, depending on the distribution, and then run these commands one by one. Okay, it's just knowing how to do it and where you want to do it. So what I want to essentially do is basically I want to take this message and I want to write my HTML. So I can say an H1 tag, and I can say a test, whatever information is given there, test HTML page on EC2 instance. So you can add this, close the tag here, and then we want to take this and we want to put this information into index.html file. So this greater than symbol here, basically what it is saying is that it's going to take this statement, create this file if it doesn't exist, and put it there. So essentially that will launch, right? So this is basically how you can provide your own software stack during the creation of EC2 instance. We are not doing this anything differently. You can always do this after you have created the EC2 instance, SSH into it, use the terminal to basically run these commands independently. You don't even have to run this last command anymore. You can just cd into it, use a text editor like Vim or Nano, and then write a full-fledged index.html file, right? Right up there, okay? So if you want to do that, that is, you can do it. But if you want to do it from here, you can do it from here, okay? So once everything is set, just hit launch instance. Okay, so you can check the launch log here. Everything is going well. And the next step, it gives you the option, billing and free tier usage alerts. We have already done that. We have already set up a CloudWatch service that monitors the different operations and how much money it costs. And if it causes, let's say, crosses over a certain threshold, then it's going to give us that notification using simple notification service. We have already set that up, so we don't have to worry about it. The other options is through this interface is you can connect to your instances, or you can set up a database and you can connect it, right? We don't want to do it. We essentially want to connect instances, but what we are interested to basically check now is to go back to our EC2 dashboard and wait for it, okay? Because essentially now you need to give some time to AWS to kind of wait for this instance, okay? So we will give it some time. And here, so if you refresh the whole page, it will essentially show you the EC2 instance that is running. I cannot bring this down any further. That is kind of a bummer, but anyways, so this is the instance and you should all see this instance essentially happening. We need to still wait because there is an initialization period. So it is running all of the different stuff that we have provided it. So all of the booting sequences that it needs to run. And in addition to that, our own software stack that we need to run, okay? It has been deployed in US East 2A, that is the availability zone, okay? We have not specified. We have been provided with the public IPv4 DNS. So if you notice here, you will get all the details. So notice the fact that there is a public IPv4 address associated with it. There is a private IPv4 address associated with it, just as we discussed. There is a public IPv4 DNS that is associated with it. So now, technically, if everything has gone smoothly after the initialization process, right? If we open this in a different browser, even if you guys open this IP address from your browser, or if I open your IP address from my browser, we should be able to see that H1 tag, basically that heading of that HTML page, technically speaking, right? There is also a private IP DNS. You cannot reach out to it, or you cannot ping it from outside, right? So we cannot do it unless we set up a VPN and we act as if we are a part of the AWS terminal, AWS stuff. So you cannot do this, right? There is no IAM role associated with it. The subnet ID, that is the subnet into which it has been deployed, the VPC into which it has been deployed, okay? The platform that it is running a version of Amazon's own Linux distribution, the name of the kernel, and all of this other information, the key value pair that we're using, things like that, we are available, right? So I will refresh this again. All right, so it has passed all the checks. Everything looks good. So I will just select this instance again. So remember, if I just select this instance, right below here, we get all of the information that is associated to that VPC. So let me just see if everything is up and running. So what I'm just going to do is just open this address and see what happens. It should say ready here. If it doesn't say ready, so unless that happens, I don't think it will be able to reach it, right? So it has still not basically installed our stuff and everything. So we need to give it some more time. Okay, so by that time, while it does its stuff, it's going to take some time. Let us talk about the process of connecting to this EC2 instances using SSH. So I'll just keep on. It should allow me to connect to it. Let us do this and see if we can connect it or not. Okay, so if you select this particular EC2 instance and then you hit on connect, okay, it will take you to this new page where it will give you all the different options which you can use in order to connect to your EC2 instances. All right. So basically the EC2 instance connect is one option. You can do the session option, but we don't have this option. And it gives you the reason why you cannot do it. But if you basically want to connect it from your browser interface, then you can do the EC2 instance connect here. And the username by default, you can provide a new username, or remember the default username is basically EC2-user. Okay, this is the default username that is. What we are interested in though is this SSH client connectivity. Now, for that, can you all quickly tell me how many of you are on a Linux distribution? Can you just raise your thumbs or something to give me? Is there anybody here who is working with
Mac
Linux?
counts, right?
So Mac is different.
Does Mac count?
Yes, yeah. Mac counts, but
okay.
How many Mac? Just 2? Okay, and I'm assuming the rest of you all are on Windows.
Yeah.
Okay. All right. So let's do for the Windows one. Mac users, the only thing in addition that you have to follow is basically this third command here, says that your key is not publicly viewable. It's an optional step, okay, which changes the permissions of the file. So your file will be called something else if you have named it something else. For Windows users, please make sure wherever you have saved this PEM file, you essentially need to open a command prompt by running it as an administrator, right? So what I'm going to do here is I'm going to look for CMD, which is command prompt, okay? And then right click on that command prompt, and I'm going to run that as an administrator in order to avoid any kind of nonsense with respect to permissions, okay? So because remember on Mac and Linux distribution, you can do the super user do command in order to override. You don't have to open it or run it as an administrator, but for us, we don't have any sudo commands as such. So we will just right click on the command prompt and run it as an administrator. Okay, so that will open up my terminal here. And I just need to locate where my PEM file is. So I'm going to basically go and find where it is. And you guys can do the same thing for yourself. Okay. So I believe it should be here. Okay. So I need to, how do I move to this location? This is going to be an annoying process. So what I'm going to do is basically cut this from here and go to the most easiest location, which is C drive, and paste it here. Is it asking me for administrator access? Yeah. Okay, so what I did is I took my PEM file and I pasted it in my C drive itself, the root directory being C drive itself. So I don't have to go browsing for it in specific directory. If you guys know where you have located it, then you can do it. So I'm going to just get out of this admin directory. And then in this location, I have my demo ohio kp.pem. So the command that we need to do to connect to this particular instance is basically run this command here. So that means SSH. And then the input is going to be our private key. And then username, this is very important. Please don't forget this, because this command here, the fourth command here, just tells you about the public DNS. The DNS will convert to the IP address itself, and then you can connect to it. But the actual command for connecting it is basically done by specifying a username, @ and then the public DNS. Please make a note of this somewhere so that you don't forget it, because if you use any kind of other platforms such as PuTTY, or if you're using, let's say, RDP and stuff like that, you have to provide a username. So the default username, if you don't change it, is always going to be EC2-users. So what I'm going to do is just copy this command, since this is the work stuff that I'm using, and I will right click that on the command prompt. Okay. So essentially, if my EC2 instance is running, which it should at this point of time, and if my command prompt supports SSH, which I believe it should at this point of time, then we should be able to connect to this computer. So yeah, so it supports it, and it says that, are you sure you want to continue? So I will just say yes. Okay. And then it has bad permission. So we essentially need to change this key value pair. All right. So
I think it's 644, by the way.
644
Yeah, I think that's what it should be.
for the CH mod.
Wondering about that. Yeah.
400 works for me.
Really?
Yeah,
All
at
right,
least on Mac.
Okay, let's do chmod 400 and then demo _ Ohio _ kp.pem. Okay, which will not be operated on Windows itself. So we need to kind of change the permissions of this file on Windows. So let me think about it for a second. It would be easier if we had used PuTTY, because I could have made it more secure there. But feel free to chime in if you guys find something here. Okay, we will stop this for the moment and we will come back to this once we resolve this issue. So we'll just pause. Okay, so once you take this public DNS and click on open address, it will say that you are not able to connect. And the drawback, as pointed out by the class, was that in the security groups, the permission that we had given for the incoming traffic was for the HTTP protocol. But right now, when we connect, we essentially use the HTTPS protocol. So that's why the security group is essentially dropping the connection when we are trying to do here. So if you remove the HTTPS here and just try to connect it, then you can see that this is the H1 tag that we gave to our EC2 instance that we had been working with. And then this will essentially show up. So this kind of verifies the fact that we are able to install our own software stack, make it act as a static web server, and you can do other stuff as well. So the other stuff that we want to essentially address is basically to connect to this EC2 terminal using SSH, right? So we have already addressed the fact that this works for Linux and Mac distribution. We just are facing some problems using the chmod permissions on Windows, which is a little bit more.
For me, it's Windows and it's working.
How did you
I think
get
what you did is
chmod
when
to
you
work?
copied and pasted, you destroyed the permissions that were associated.
No, not necessarily, right? Oh, you mean when I moved it to C drive?
Yeah.
That could be a reason.
I moved to my
But he moved
Google
it as
Drive
well.
and I am referring from there and it's still working for me. I did almost the same thing.
So you did not do any changes. So you just went
No,
here, you
nothing.
went to connect, and you just ran this last command here.
Yeah, it worked without any problem.
Okay, so now we are in the typical debugging area where it works for one and it doesn't work for the other one. The same thing. All right, let's try to solve this. This is the worst kind of situation to be in because we cannot reproduce the same problem. And then if you cannot reproduce the same problem, we don't know what problem it is. So for me, for those of you who have already worked on it, please go ahead. And so if you're watching this recording and if it works for you, that's great. I have a own problem of myself, so I have to fix that. So what you can do in the meantime is you can pause the recording. And for those who are in call right now, first terminate this instance. So let us go ahead. That's the first step that you should do before you work on anything else. Go to actions or go to instance state and then go to terminate instance, not stop it. Stop allocation still is there, terminate it. But first and foremost, let's do a hand show. How many of you were able to SSH into it? Can I get like a raise of hand or a thumbs up emoji or something that gives me some understanding, at least for those who are working? How many of you were able to connect to the SSH? Let me know. That's it, just 4. Are the rest of you trying?
I think everybody else was in Windows.
Sounds like it.
Okay, so only. So how many of you are in Windows or were not able to get it, to SSH into it? Okay, I'm not sure what is happening with the class, so just assume that it worked. So anyways, for those of you who were able to get it to work, please terminate your instances. I will be starting a new instance because I destroyed my key value pair. So I need to regenerate that and associate that to instance. So I'm going to terminate this instance. It will tell you that you have a elastic block storage that is associated, and if you terminate the instance and if you do not back up your EBS volume, then it will delete all the data that is associated with the instance, which includes our HTML directory that we created and the index.html file that we have there and stuff like that. That's fine. There's nothing there. That was just a demo to understand how to create a static website, right? So we will just go ahead and hit terminate. The instance state will show you that it is shutting down, and then give it some time and it will kind of take care of that, right? So in the meantime, what you can try doing for those who were able to work on it is to basically create a new distribution, but this time using Windows image. Okay, so if you follow the slides there from, I believe it is self-exercise here. So in slide 29, so please try doing the self-exercise there. And then for Mac users and Linux users, you will need a remote desktop protocol client. Okay, so if you go to slide 27, you should see I have provided the link to download the applications that is necessary in order to download your own RTP client for either Mac or for Linux distribution. So try working on that while I kind of work on my stuff here and fix this. Okay.
Professor, just one question.
Yeah.
If we have some data on volume, maybe some configurations which we don't want to delete from the volume,
you have to create a snapshot first.
Snapshot.
So here you can see at the very left terminal, you see the elastic block storage, right?
Mm-hmm.
So here you can create volumes that are mutually exclusive from the EC2 instance. So this gives you the ability to kind of connect your volumes to the EC2 instance separately. So what happened is in the previous exercise, we created that volume, associated that volume with the creation of the instance. So when the instance goes, the volume goes. But if you create the volume outside of that instance creation, then you can basically detach the volume and then terminate the EC2 instance without losing the volume. That is one option. And then when you want to delete the volume itself, but you still want to save the data, you essentially go to snapshot, and in the snapshot, when you create a snapshot, you have to specify what volume are you using to create that snapshot. So there you have to specify that particular volume storage. So that way you can take that snapshot and save it somewhere else or download it onto your computer, later on use it. Make sense?
Yeah, thank you.
Okay, so let us go ahead. And I had another idea actually. I can actually try that. Let me try that idea. If not, we will try it. Okay. So it tells me to write delete. So just write delete. Create a new pair. Give it demo underscore Ohio. I think I just have some idea. So now it is by default telling me to download the PPK because it thinks it doesn't work. Okay. So now I have my stuff again. Let me just double check my directory. So it's there. All right, it is there. So now I will go to my instances. Okay, so now this is terminated. Before closing off your session at any point of time, just make sure everything is terminated. Nothing should be running. Okay, so that is the main thing that you have to do. So now I will go to launch instances. And I will say here demo dash EC2 dash part 2. Okay, go to browse EMIs, select Linux, T2 micro, key value pair, and this is the key value pair. Let me just refresh this, make sure that there's nothing there. Okay, we use a select existing group, select our demo SG Ohio, 8GE. Okay, no advanced detail. I don't want to create anything this time. Everything looks good. If everything looks good, just hit launch instance and let it launch. Okay, then go to our instances and it is pending. Let's wait for it. And while we wait for it, I want to find something called this guy. Okay, finding this guy and waiting for this to pass its check, and then we will move on to it. Okay, so I don't want admin access and all those things. I'll just change my directory. So where am I right now? I need to find that first. So let me just try that. Okay, so I'll run ls. Okay, cd find you.
It occurs to me that it might just stick the SSH key in the default location and just running SSH will work, regardless of what directory you're actually in.
Mm-hmm. So without moving it around, that's what you're saying?
Yeah. Because that's what it'll do on Mac or Linux. It just puts everything until the /.ssh. And then when you hit SSH, it just looks in that directory.
Well, I still want, this time I'm going to copy it instead of cutting it, so I don't have to generate it again.
That's probably a good idea too.
Because I want to try this here and see if it is a Windows problem that I'm facing, or is it something altogether different. Okay, so let's wait for the moment of truth. There used to be a refresh button here that does not require me to refresh everything. Okay, so let it pass the status check, and then we can try to debug this, at least on my system, as to what the problem is. I don't think this would allow me to do it, but we can try. Okay. So refresh it again. Come on. Let's go to connect. Let's try this. All right, I think I can make it work using this. Try this. All right, I think I know how to work this out. Bash. All right. Let's see. Okay, is my instance running? Okay, so everything looks good. So now I can debug this and see what is happening. All right, let's do chmod 400 and then demo Ohio. Okay, and then copy this command, paste it, and go for it. I want to continue. Yes. Okay. All right. So it's a command prompt issue. Everybody's familiar with Git, right?
Yeah.
Yeah.
Yep.
Okay. So I just accidentally checked one of the messages talking about Linux subsystem or somewhere. I lost who messaged it, but that kind of reminded me of the fact that Git Bash allows us Linux-like terminal as well, very similar to Putty, what it does. So I ran that as an administrator. I moved my key value pair outside of my downloads directory into the C drive. Okay, so here I am in C drive. Essentially, I ran the same command here, which says chmod 400. That is, we are making it private to the outside world. So people cannot kind of access the private key and modify it and stuff like that. And then I copied this SSH command with the input of that key value pair, EC2-user being the default user, and then basically specifying the public DNS of the EC2 instance that we are trying to reach out. So essentially that will allow you to connect. It will ask you, do you want to connect? And you will say yes here. And then that will take you here. And then at this point of time, you can see that you're logged in to the EC2 instance as an EC2 user. Okay. And then from this point onwards, you can do the same set of tasks that you did before. So we don't have anything here. So if you want to change the directory to var www HTML, you can do that. Put an entire website there, not just your index.html file, but you can create subdirectories such as your pages, your CSS file, your JavaScript file, and you can put it there. So this is basically, if you're ever looking for a way to run a server that can be pinged from the outside world for a static website, then you can use EC2 instance for it, right? And it's pretty cheap, even if you're not working in the free tier account. All right. So let's look into fixing this again using the Windows directory and see if we can make that work. So for those who are still not able to fix this issue, who are in the Windows, just install Git. So what the solution is, you basically go download Git. You go to download Git, go to Git SCM. In Putty, you have to change it because you have to use a PPK file instead of a PEM file. So you cannot use it. So you have to go back to the key value pair, download it either as a PPK file, or you have to go through the slides where I have the instructions at around, I forgot which slide. From slide 23 to slide 25, you have to convert the PEM file to PPK file and use that in Putty. So either you can choose to go that route, or you can choose to go to a lesser resistance route, which is just to go to download to Git, download it for Windows, let it run, and then you can just search for Git Bash. So if you look for in your search command, if you look for Git Bash, you right click on it, run it as an administrator, go to wherever your file is, and then run the specific set of commands. Okay. So work on that. And while you work on that, okay, so if Git is working, Git will work because essentially we just need the Linux commands. And Git Bash is basically the Linux subsystem that interacts with the Windows. It provides that overlay to run our Linux commands. And I forgot I use that with Visual Studio Code all the time. So anyways, so this will let you run it. Okay, so for some of you, you were able to work with command prompt as well. So I'm going to try that again and see if it was because of I moved the file there, but it shouldn't be, because it's clearly telling me that it's a permissions issue. They don't like that. So I can basically control the permissions. So what I'm going to do next is I'm just going to open another command prompt, and this is just to debug it, just to see if we can get it to run without having or without moving the file, if that is the case or not. So I'm just going to get out of here. Here, I think I need to cd into users. Oh, ls doesn't work for sure. Why not? Okay, and then cd into this. This, I think I can cd into downloads. Yep. Okay. Let's copy this command here. Come here and run it. Okay. So Ryan was right. So since I did not move my stuff from the downloads file, the file that was already there, I did not move it to C drive. And I just ran this command, and apparently Windows doesn't complain at all regarding that process. So two options here. A few things that we have learned that we have to keep in mind is if you download it on the Windows and you use the command prompt as an administrator, okay, if you do not move the file and wherever the file was initially downloaded from AWS platform, if you just use the command prompt to SSH into it using the command that has been provided by AWS, it will go through without any complaint. Okay, so that's the first thing that we learned. The second thing that we learned is that if you move the file somewhere else, for some people it worked, but for me it didn't work. And essentially the reason for that was the permissions were disturbed. So if the permissions are disturbed, then essentially on the Windows platform, using whatever technique that you are aware of, you basically need to minimize the permission of your .pem file so that it is not publicly readable. So you have to take away the read-write access of your PEM file. Okay. Otherwise, if you want to run a Linux-based command on Windows, there's no problem if you're in Linux or Mac distribution itself, everything is good. You have two options. You can either download Git and use the Git bash, which provides you Linux-based commands for working on the Windows directory, right? So you can run all of the different Linux commands such as chmod, SSH, and stuff like that. Well, SSH is not a specific Linux command. But you have to make sure that you run this Git bash as an administrator. So that means when you search for it from the Windows search bar, you need to right-click it and run it as an administrator. Okay, that's one step that I always like to follow. The other option is to, if you don't want to work with Git bash, you can either choose to work with PuTTY, but PuTTY requires you to work with a .ppk file rather than a .pem file. So if you are very sure that you're going to work with PuTTY, when you are going to create the key value pair, then you can download the key value pair as a PPK file itself from AWS platform, instead of going through the hassle of converting the .pem file to PPK file by yourself, which essentially this feature was not present a year ago. So they kind of changed it at this point to make our life a little bit easier. Okay. And once you're connected to your terminal, essentially you can do whatever you want on just like working at a local computer. So right now, you are essentially connected to this EC2 instance, which is running here, right? So any type of application that you would want to install, you can use the CLI interface and you can basically work with it. Okay. So were people able to resolve? Can I get like a yes or no or some feedback of some sort for those who were stuck? Yeah. All good? Okay, so I see two people saying yes. I'll take that as a yes.
The git bash route worked well for me. I didn't try it with PowerShell, but I enjoyed git bash.
Okay, essentially, if you don't move the file around, then you can get it connected using command prompt itself. So for those Windows users, right, if you don't want to download or if you have not downloaded git bash, then essentially just run the command prompt as an administrator or PowerShell, whatever you want to. Go to the directory where you have originally downloaded the .pem file, which for me was the downloads folder, right? And then just run the command that is given by AWS to connect using SSH, which is basically this. What is important, regardless what platform you use to connect, is to always remember that the connection protocol has a username, @ and then the DNS. And the default username, unless you change it, is always EC2-user. This is important because when you create a Windows distribution, right, you will have to connect to it using an RDP. In RDP, if you remember, so let's say if we look for remote desktop connection, if you go here, it will ask you about the computer, right? So right now it just automatically catches the fact that we are working with this, right? So it will give this, but the username is not particularly administrator. So you need to go to additional options and you need to change this username to EC2-user, because that is the username and this is the computer, or basically the public DNS address that is provided for that EC2 instance, right? Then you need to connect and it will ask you for uploading your PEM file at some point, right? So you need to upload that as well. So please
When
try
I
that.
tried with the Windows instance, it gave me administrator as the username.
Very cool. I do not have an answer for that. So I will have to double check and let you know. Okay. All right. So essentially, and where did you upload the PEM file?
So when you create the instance, then you say connect to instance under RDP, it says like session manager and then RDP client. It gives you like the username, and then you can download the RDP file. And then you, like you said, I uploaded my private key to decrypt the password, and then it gives me the password and PIN.
Yes, the decryption process.
Yeah.
Okay. Yeah. I remember that now. Okay. So essentially we will have to decrypt it and we will have to paste that password. All right. So I think the instructions is provided here. And is the RDP client for Mac the same as that of Windows? Do you see it as the same way like this?
Not exactly. You have to download it from the Mac App Store.
So it is completely different, right?
It's a little
Not
bit different.
completely, but
Not completely.
different.
It's just a little bit different in terms of the user interface, but how it works is the same.
Okay, got it.
Yeah, once you get through the RDP client from the Mac, then you will see that Windows RDP client screen.
Right. But yeah, when it prompts you to download the RDP file, so you just run it and then it does everything for you.
Okay, sounds good. So if you look into slide 28, basically we have the step-by-step process of connecting through the RDP instance. Okay, so please try that, at least give it a shot. For those who are on Windows, you don't have to download any additional pieces of software. So try that out and work with that and see if you can get it to connect as a self-exercise. Okay, otherwise we will do it again in the next class. All right. So any final questions? And don't remember to terminate your instances. Please, if you are done working, if you don't want to try anything else, select the instance, go to instance state, and then terminate. Don't stop it. Please terminate. Please remember this, okay? Please terminate your instances before signing off from your account, okay? And don't just assume that it has been terminated. Wait till the instance state actually shows terminated, just as a safe practice, okay? In case anything went wrong during the termination process, you just want to be aware of the fact that it has happened, okay? So please wait till you actually see you're terminated and all EC2 instances have been terminated, and then sign off from your accounts. All right, so I will stop the recording here and we will continue our discussion on the load balancing and auto scaling groups in the next class. So that basically allows us to let AWS handle the number of instances that should be running based on different criteria that we will have. So we will talk about that. And once we are done with that, we can then move on to storage, which is basically the elastic block store. And then we can work with the volumes and the snapshots, and then we can see how to create those different stuff. Okay. So, all right. So we'll stop the recording here and I will see you all online again in the next class.